colors in varying light levels.
Okay, so just to start off, we're going to talk about melanin. Melanin is a natural pigment that is found in the eyes, the hair, the skin, and lots of stuff. If you have a lot of melanin concentration, that means you're going to have darker eyes or a darker skin tone or darker hair. If you have lower melanin concentration, you're going to have a lighter skin tone, lighter eyes, and lighter hair. Melanin is both found in the retina and the iris of the eye.
Okay, genetics code for about the majority of the melanin. The brown eye color is dominant, the blue eye color is recessive, and the green is recessive to brown but dominant to blue. And this graph right here is basically the eye color percentage of the world. 90% of people have brown eyes, 8% have blue eyes, and 2% have green eyes.
So for this next slide, I'm going to get out our fancy eye that I named Jill. So basic structure of the eye is made out of the cornea, which is this outside part, the lens, and the iris. The lens in the cornea are used to focus eyes into the pupil, which is this dark spot in the eye. And in the back of the retina are these receptors called rods and cones. Cones allow for vision in the light, which are your day vision, and rods allow for vision in the dark, which is your night vision.
So all of us age, and with age your vision usually decreases. So the melanin is in the retina and it affects the vision quality. So as age, enzymes eat up the melanin and therefore your eyes can become lighter and your vision quality decreases.
Okay, so our hypothesis for our experiment was people with more melanin concentration, brown eyes, will have better vision quality than those with lower levels of melanin in their eyes, which are blue or green eyes.
So for our materials we use tape, measuring tape, the Snellen eye chart, and a room that could vary in light levels, which means they had a dimmer.
Alright, so for our methods, we gathered 3 groups of 5 people. We had 5 brown, 5 green, and 5 blue. Alright, and so what we did was we set up a line of tape. We taped this chart to the wall, and then set a distance of 20 feet away from the wall and had the participants stand behind the tape. And then we asked them to read the letters, as many as they could, in the light. And then after that, we turned off the light except for a dimmer in the front of the room and asked them to read it again. And then we gathered these results. And what we did, how we recorded that, was we recorded what line they could read to and how many mistakes they made. The results are, we have the bright, and how we recorded these were we assigned each of these letters numbers. There's a total of 35 numbers that they could read to, and we calculated in the light and the dark, and then made averages of each color.
So these are the mistakes that were made in all of the light, the dimmers on and the light. As you can see the graph, this is participant number 1. For brown, the bars are representative of the color. So the brown-eyed person had 4 mistakes, and the green-eyed person had 1. And since there's no blue bar, that means that the blue-eyed person had 0 mistakes. And the same procedure for the dims. Brown-eyed person had 5, and green and blue had no mistakes. These are the averages.
This is what I was talking about with how many they got correct. We figured that this would be a better way to record the data because it eliminates both variables and puts them into one. So we gathered how many they got correct, and brown is superior in this group, and blue is a close second. And then this is in the dark light, and all categories decrease significantly, but brown is still on top.
So, we had 20 feet in front of the eye chart. That's the standard amount to read a Snellen eye chart. And so their feet were at the 20-foot mark. However, they leaned over and read the eye chart, so they might have seen right better or closer to 4. Corrective lenses were used, and although they help with vision, they might not have the same vision quality. So person number 1 could have 20/15, while someone with glasses could have 20/20. And this is the first experiment of its kind, so there are different further studies that we could have done to have better results or enhance our answers better.
Alright. Like she said, there's never been any studies that have connected the two between melanin concentration and vision quality. And so this could help our further generations, and you could study more into genetics on how to make your eyesight better or which eyes see better.
And we would like to thank our mentors, Mr. Williams, Ms. Morgan, Ms. Rogers, and Ms. Santiago.
Would it make a difference if somebody wear contacts?
The corrective lenses that we talked about were for contacts and glasses, so both help your vision in the same way, it's just not glasses.
Yeah.
Did any of your participants wear glasses?
Yeah.
Yeah.
Yes. We calculated, or in the experiment, we asked them if they had any eye illnesses, such as like glaucoma or farsightedness, nearsightedness, and we asked them if they could see better without their glasses, they could take them off.
So do you think the melanin causes more diseases in your eyes? Is that affected too?
We didn't come across that, but what we studied was that melanin did have an effect on vision.
Yes, like lighter colored eyed people, they're more sensitive to light based off the amount of melanin that they have. So it could be easier for them to potentially get eye health problems.
Is that just because their eyes are so light when they see light and affects their eyes?
I guess I'm still unclear. So it's possible that all of the brown-eyed people had corrective lenses on, and that maybe all of the blue-eyed people hadn't seen an eye doctor and didn't, you know what I mean? Like, that's possible, right?
Yeah, we did have some people that didn't have the best vision. You need glasses, I'm sorry. But we just asked them to read to the best of their ability, whether they had contacts or glasses on or not, because we figured that could be, we don't have enough people with brown eyes, or with blue eyes, so we just figured we could take whoever we needed to, and if they had corrective lenses, that's what we had to accept, because that's all we had available to us.
How many participants did you have?
15.
Okay, I guess we're out of time for questions. I'm sorry. Thank you for watching my presentation.